Hi folks, we're going to take a look at this question from an old homework. So we've got this suspension bridge and they tell us that it's 140 meters long, and they give us some information as to how to hopefully calculate the height of this bridge. Okay, so they say from the ends of the bridge, the angles of depression of a point on the river under the bridge are given here. So what we have, let's say here's below the bridge, we've got the bridge. Okay, so this represents the bridge. We have that this is 140 meters long, and they say that from the ends of the bridge, we're looking at a particular point. Okay, so they're saying that the angle of depression to this point here is, from one side is 41 degrees, and then the angle of depression from that point there, as you're looking at that same point, is 48 degrees. Okay, and from this, apparently we have enough information to calculate the height of the bridge. Now, the height of the bridge, of course, is measured vertically, and I'm going to choose to draw that line for the height of the bridge right at that point that we're looking at from the ends of the bridge. Okay, I could take it anywhere. Now, of course, we're assuming that this is a flat space, a horizontal space, as we usually do. And what we have here is we have two right-angled triangles, which is good, for which we know the angles. That's also good. What's not good is that we don't know a side length. All right. However, we have information related to these two adjacent sides to the angles that were given. So we'll call this h for the height. And since I have no information about the hypotenuses, and I don't think they're going to be of any interest to me, I'm going to look at these adjacent sides. And if I want to work with these sides, I need to give them names. So if I call this side x, then I can write this other side as 140 minus x. All right. And what we have is we have an angle and two sides that we're working with in each of the two right-angle triangles, but because we have two unknowns, we're likely going to have to solve a system of equations. All right, so let me start with the right-hand triangle, and let's write an equation for that. So again, I'm going to use tangent, so I have no interest in the hypotenuse, so I have that tan of 48 degrees is equal to opposite over adjacent, so h over x. And then from the other triangle, I can say that tan of 41 degrees is equal to h over 140 minus x. All right, and I have exactly what I thought I'd have, a system of two equations with two unknowns. And this is what we're going to solve. Now, we have to make a decision here as to whether we're going to approximate the tangent values now or try to do it all at the end. So I'll solve this problem with the tangent values staying exact. Okay, but if I do another problem, I'll just likely do it where I'm approximating them. And again, if you do approximate, keeping 4 decimal places will ensure that you get a very accurate answer. Okay, so step one is I'm going to isolate the h's here. It looks like to be the probably the easiest thing to do. So if I isolate the h's, I've got h equals x times tan 48 degrees, and then here we have h is equal to 140 minus x times tan of 48 degrees. And now I see that these two h values are the same, so I can equate those two expressions. All right, so let me do that here. So we have x times tan of 48. Now here, this is just by convention that we tend to write the numbers and variables before the tan 48. Just keeps things from getting confusing. Equals, now I know I'm going to have to distribute this, so I might as well distribute it now. 140 tan of 48. And I just realized here, this should be tan of 41. Sorry about that. Okay, let's fix that here. Okay, because we were working with this left-hand triangle. And then here we've got minus x times tan of 41. And we're going to solve this the way we solve any other linear equation, is we're going to collect all the x terms to one side. So we have x of tan 48 plus, is that changing from a subtraction to an addition, x times tan of 41 equals 140 times tan of 41. Right, now here essentially we have two like terms, and how do we add like terms? Well, we just add their coefficients. In this case here, the two tangent values are their coefficients, so I can write x times tan of 48 plus tan of 41 is equal to 140 tan of 41. And now I can solve for x by just dividing out this new coefficient. So I have x is equal to 140 tan of 41 all over tan of 48 plus tan of 41. And now I can approximate that on my calculator. All right, so make sure you're careful when inputting this. Okay, we've got 140 times 10 of 41, so suggest you go equal there and divide by. Now make sure you open up a bracket because you need to divide by this whole thing. So here we have 10 of 48 plus, don't forget to close the bracket there, plus 10 of 41. And that gives us 61.47. Okay, but of course it's not actually x that we're interested in. We're interested in h since we're looking for the height. So that's where we can take this value and input it into one of these to find h. I'll choose that one there because that looks quite a bit easier. So h is approximately equal to x, which was 61.47 times 10 of 48. And so here I still have that number in my calculator. So times 10 of 48. And we have 68.3. Okay. Now I notice here in the question they say to the nearest meter. So it'll just be 68 meters. And there you have it. All right, so just to recap, step number 1 is to get a good diagram. Step number 2 is to see that we can't solve this directly, so we had to create 2 right-angle triangles, and then of course realizing that you needed to work with 2 unknowns, hence a system of equations. That's it for this one.